I don't wanna be. I do. I'm feeling groovy.
Hello, welcome everyone. Thank you, Silex, for having us. It was pretty interesting so far. Hope you've enjoyed everything. And yeah, and yeah, this is funny because Valérie already introduced the fact that she wouldn't talk much about Haxi, and I will talk even less about Haxi, which is very funny in a Hax conference, especially. What happened is that my name is Nicolas, and I'm a future former flasher. So I will have done Flash in a couple of months, probably, and therefore I'm like many other flashers. I'm looking for an exit, like a way to keep doing the things I like with new tools or new technologies. Acknowledge that Flash is not in a very good shape those days, and it will probably not recover. So. Last year, I think it was in September, I attended a session by a guy called Andreas Röning. I don't know if the O with a stick in it sounds like Rö, but he's a very good Flash developer, and he also had to move forward, and he started using Haxenemy, and his session was about how easy and it was to swap from one to the other. So it got me really interested, and then I started playing with it, and for a while, playing is really the world. I mean, I haven't produced anything, but it was convincing enough for me to, for instance, give a workshop to some poor, unfortunate students, and they suffered greatly when I had them install both Flash Develop and Haxenemy, and they after that they wanted to resign and quit school, and it was really seamless, and I was very surprised how easy the younger generation can catch this kind of earthquake, like Flash is dead. What's the problem? And it was pretty encouraging, and so I do mostly graphic things, not always for a living, because website I do websites for advertising, and most of the time they don't just want fairy powder or unicorns, rainbows. They will also want an actual app or website behind it, and but usually they have this word here, which is the wow effect. That's why they call me usually. And this session is not about Haxi. This is okay. And and since there are things that I've done in between, and I will spot them and say, "This is Haxi enemy," and then you wow like this, okay? I've got a couple of topics I've been working on. Keep speaking, get used to it, because it will not stop. And a couple of topics, most of which are related to graphics. And I don't like, it's like choosing between your children. Like, do you prefer your son or your daughter? I love them both. So I've piled up literally topics and stuff, and I couldn't find a clever way to present them, so I decided to present them at random. And as I said, random sucks, and so it's a pseudo-random, so I can get an idea of what's going to happen before it actually happens. And so that's why I've got this PRNG class. It's a pseudo-random number generator that will it is a seed based, so you start with an int, and then it will output a seemingly random sequence that is always the same, depending on the first number you passed it. And so just to prove that I'm not cheating, this is today's date. By the way, I like very much the 24th of April, so if you prefer, we can take, well, anyway, shut up and compile. Okay, this is not, for instance, this is not done with Haxenemy. I started with it, and I had some issues with 3D mostly, and so I decided to build an Air app instead, and it works. But okay, so imagine it also works with Haxenemy. Okay, so this is a potato, but a virtual one, that is. This is a list of the topics represented as dots, and of course you can't see shit because there is too much light in the room, but it's beautiful if you look at it on my screen, for instance, and so that it will be done, there are lights over there, and so each dot is an entry, like not all of them are documented, of course, because I wanted to have like a little sample, some pictures, blah blah blah. So it would be too much work, and anyway, I couldn't like finish anyway. And but some of them are documented, and this little ball that in the top right corner is the current point we're at. Okay. Oh, and one last thing: the little things you can't see either. In the top right corner. Metrics based on the text of the entry. Like this is called. It's fascinating. It's called. Forgot it. It's about generating, shifting the feelings from one field to the other, and I think it's called synesthesia or something. Well. And then I took an input, and then it gives colors, it gives shapes, and it gives a global direction of motion for the object in the middle. Who cares? Move it. Okay. Oh, yeah, and to make it a bit more interesting, I've put a timer so that if I speak too long, then it will shout. Okay, hiccos. Oh, my favorite topic. I think, yeah. So when you don't have a good idea, graphically speaking, just leave a trail. This is what hicco stands for in that case. So this is pretty. Well, it's like it's just letters. Actually, these are letters that go away from a center point, and if you just print them and clear the screen afterwards, then you just have something extremely poor. But if you keep the traces, if you keep the trails of the motion, and if you 50% of the nowadays creation with a computer rely on trails. So because it's so impressive to see a motion, for instance, like a motion capture, and you won't remember anything from a motion capture. But if you draw all the lines and everything, then you've got beautiful objects. Like graphically, it's really very interesting. And strangely enough, it's also something that is a very, very ancient topic for artists in general. Like there was this guy, Jules-Étienne Marais. No, not that much time. He would take pictures and try to decompose the motion of animals, horses, blah blah. He even invented a photographic shotgun, and it's a beautiful piece. It's somewhere in a museum in Paris, and he was literally shooting to decompose the motion. Just okay. My favorite topic, convolution. So well, that's okay. You all know how it works, huh? It's like no, maybe you don't actually. So I think So you take a picture as an input, then use a kernel, that would be this little guy, and you ask it to compute the output pixel. You use the input data, filter it through a kernel, and then output the desired color depending on what you want to do, enhance, like blur, whatever, blah blah. Okay. Lots of things to do with this, and yes, and that's what happens when you mix. So this grid in the middle that is no more on the screen can have any shape, and which is that little shape up there is a kernel, and I think you can change it, and you can obtain. Of course, you don't see shit, but imagine it's beautiful, yeah, and yeah, so you can get very, very interesting, and it's extremely cheap. I mean, both not in terms of time of computation, because it can be, depending on the implementation, can be extremely slow and okay. This means I was too slow. Okay, so epicycloids, these are wonderful creatures. I like very much the idea of doing a lot with very few things. So in that case, you've got two circles, okay, and you have one rotating around the other and rotating on itself. And depending on the frequencies you can get stupidly complex motions and objects, like, and really, it's. And you can also design some, the cycles for the planets and everything, like when it will come next, blah blah blah. Depending on because this can represent gravity fields or revolution times and everything. But it's crazy. Like there are like 20-ish or something, different size, different motion, rotation times and everything. That's pretty interesting. And it's a hippie, you still have them, because it's outside the circle, and later on you can see the hypo, which means the circle lies inside the circle. I don't know if oh well, that's extremely interesting, Nicolas. Yeah, this is wow, who cares? You got it. Okay. Haha, gotcha! Oh, patterns. Don't know if I have, yes. I love patterns. They're everywhere, especially natural patterns. You're probably sitting on a pattern at some point, and they're just everywhere, and I love them. Patterns in the snow. This is a cheese crust. How could you tell, huh? And I like especially the natural patterns, because they are just. That's just at the point where you will project something on it, because there is nothing but a chemical or thermodynamic reaction, and except for this case, this was intentional. I mean, and but it gives such a great complexity with very simple means like gravity or just like capillarity and everything. And I can recommend a series of books by an English gentleman called Philip Ball, and he's a physics writer or something. And he did a tapestry in 3 parts, and 3 books about shapes, flows, and branches, and it's really great. I mean, you can't see the world the same before and after, and just like this is big, and it's awesome. Okay, haha, gotcha. Oh, tiles, my favorite topic. Talking about little means and big effects. This is probably where I realized the most accurately how few inputs you needed to create a broad variety of images, patterns, and everything. So this is just randomly applying different mirroring, like a kaleidoscope or something, on the top left picture. And depending on how you do it, you can just copy a corner and duplicate it around the center. Or flip it or slice it and then flip it halfway, mirror it and everything. And the code behind it is ridiculous, like simple. If you can draw a triangle, which is the case with enemy, then you can just do anything. I mean, it's like crazy stupid. And tiled, I've got something about regular patterns later on, maybe. We are not too late. DNA, my favorite. This was done with enemy. Just kidding. Okay, so this is a very interesting field actually. This is where my students were completely lost when I started showing them this. Like, what the fuck? And so it's a very naive implementation of DNA, like genetic algorithms, like something that looks for something to get better, blah blah blah. And this is a very, 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 very simple example. We had a target, which is a number, and then in time the algorithm will grow and regenerate objects that are more and more clever and more. So this was a number, this is a string. I will spare you this one because I don't have much time. But it can the good thing is that it's and that's also something I like to insist on. But it's a one-dimensional process, so which I like very much because you can then apply it to anything. It's such a simple thing to. Well, there are like 3 methods or something to implement, which is not a lot as compared to macros or something, and then you can get it to work on basically anything, which is like finding shapes or finding whatever. Random. Prefer the previous. No, don't want to play. Okay, I'll just no. I like very much the star finding thing. So this one, so cute. And you can see all of them are like, hey, me, I want to be the first. And yeah, got there. Very important to not to be too serious. And this is the same as before, but 2,000 iterations are applied to the object instead. So it's kind of extremely clever and growing and breeding extremely fast. And you can see it almost matched the shape it's supposed to mimic. Okay, now we can go. Random. Oh yeah, can't remember really what this was, but oh yes, random distributions. It's very important. Like I told you, random sucks, which is true, and at least absolute random sucks because when doing graphics, you need to have some control over it, and this, for instance, is a kind of little variation which is not done with HaxEnemy because it's processing. And this is, for instance, how if you call a random, then you will have some figures dispatched between 0 and 1 quite regularly. Now, if you combine 2 randoms together, then you get something a bit more random by random, which will concentrate the values near 0. The square root of a random, which will push the values next to 1. So you have fewer and fewer values in the center and more values next to 1. And these are very simple operations. You can just kick out some frames of numbers, which works pretty well. This one is funny also because you've got a lot of values around 0.5. So you just half a random plus a random, and then you'll find the values in between. This one is completely awesome. It's the same with a steeper slope. So well, who cares? Anyway. Particle physics, my favorite. Done with enemy. No, this was just bullshit. It was for my students, basically, and for me also to learn how it works. But you can do like pretty interesting things with very simple rules. Again, it's like you've got if you see particle, push it. That's the red dot, and if you see particle, attract it. That's the blue. Okay, and then you've got a system that is creating like a not even emergent shape, like it's complete chaos, but it can generate. If you leave trails on that, it's beautiful, and you will see lots of them in data visualization, motherfuckers. They all use this because it's very hard to do something clever with data. I don't like really the data visualization. It's too many people full of themselves, and well, I don't like many people basically. Okay, so that was it. Well, Fields particle is pretty interesting. My students were pretty. If you have students someday, just teach them particle physics. They will love it. Because it's easy to understand, to implement, and to push further. So it's like enemy in a way. Okay. Speaking of which, before that, in Flash we had Eagle, and Eagle sucks. It's a like low-level implementation for the GPU access, and they did it, which was pretty interesting. All this test, and I don't know if I have something else, but it's really a pain. It's extremely difficult. Like when I saw what was done with HLSL or XLSL, things like that, it's so appealing as compared to formatting a string with macros in it and pushing them on the GPU, and that's crazy. It gives good results. I mean. Well, not what I expected, but fairly good results, but it has a cost, and not willing to pay it. Yes, this was also for my students, so again, yeah, extremely impressive. I think you haven't never seen that before. It's a game of life. Again, a very, very simple means and great output. I mean, you can cover very large surfaces, and the problem is that it will at some point stabilize in a state like depending on the rules. But there are some variations around it that can create more interesting shapes, and that can then therefore be re-injected in serious shit like game making, or you can see a level of worms, or I don't know, whatever. It will. So altering a bit, having a very small, very simple principle, altering a bit the rules, and then ta-da! You're the king of the world. And that's funny because also this, I told you about the patterns and pattern formation where you can see shit. Well. It's a noise, but it's very funny to use completely known rules and apply them systematically and see a chaotic system emerge, which is always fascinating. Like it's a computer; it's not supposed to create random. It cannot, and since it can. I think time's up. Yes, almost. Noise. Noise is interesting. Much more interesting. So, no, that's the one. So first, I told you about random and how much it sucks. And noise. This kind of noise is very good to mimic the television when there's nothing on TV, but it's a bit dry. So you can use it, but it's a bit. This was random. Noise, on the contrary, is like more like okay, you'll see. So this is what happens when you use a bigger random seed, random set, random input, and then just interpolate between two colors next to each other. So okay, if you don't understand, I will explain it around the beer. But that's a very simple operation, and then once you have this, you can redo the same operation and at different scales, and then you obtain what's called a cloud, which is not that different from what we've seen before. And it's only about interpolating and creating noise at different scales and interpolating and combining the output color, and it works pretty well. And finally, when you have this, then you can even mimic. You can't see it; it's much better on my screen. But this is like a marble or something. Marble, the stone, not the. Okay, what next? Crayon. Yes, my favorite topic. Okay, so this is an exercise I've done in. That's what I was telling like 2 hours ago. When I don't know a language, usually I port what I know, just to make sure that result is what I expect it to be. And so this was something I've done a long time ago, and it's just to mimic a brush stroke. And trying to have like shapes that follow, mapping a bitmap on like a ribbon. I call it a ribbon. And this was done in Flash. And yeah, that's how it's built. And a good thing is that you can like animate the thing in there. So because it's possible. And then you obtain like extremely complex things when just basic. There is no math almost in there. It's crazy stupid, but I love it. Still my favorite after all these years. And I tried very hard also to inject this in a project, like in a professional project, and they wouldn't just. They would laugh at me. Poor bastards. If only they knew. This is awesome too. You don't see anything, but it's awesome. This is the attractors series. Like it's not it's kind of like the family of the fractals or things like that. I wanted to do something delicate, but it didn't quite work. And in fact, it's a formula. Like all the attractors were initially created to model meteorological phenomena, clouds, and the simplest models are really simple. But after that, there was this guy Lawrence, and he kind of created the whole thing. And after that, some people, very clever people, also studied it. And this is a Tinkerbell curve, by the way. And they studied it, and they made it insanely complex. And you can have like to draw this, you can have like 26 variables, like which is too much. But it gives very nice results, and you can find lots of chaoscope, or like even now with WebGL you can find live versions of this, so you can just compute this in real time and everything, just tweak the parameters, and yeah, it's beautiful. Attractors, and then the animation was strange attractors. This is even better. Tools, yes, there's nothing to show here, but as I told you, usually when I tackle a new language, I need to be able to check that what I learn is what I wanted to learn, and so I usually build some very small tools. It can also be used to demonstrate a principle, like how something would move, or how proof of concepts call it. And I think it's really, really, really very important, especially when dealing with graphics, because you can mime it, of course. The creative director I'm working with currently is usually miming me the motion of the fades, and then it goes. But we can only start working when I've done a prototype, or built a tool that allows me to show him and to make small variations in this principle of animation that he wants to reach. And it's a very interesting interface between people. they get it instantly. I mean, when you build the tool, and that's it. Because most of what I've shown are basically tools. My favorite topic. I think that's the dude. You've seen this picture everywhere, I'm sure. This is Pierre-Étienne Bézier, the proud inventor of the Bézier curve. It allowed us to build this kind of cars. How cool is that? I took this picture next door, like often. I didn't know that it was still legal to drive this, but it seems to be the case. And anyway, it's a collection piece. And yeah, the problem at the time was to draw this kind of curves, and they could be the coolest cats around for a while with these systems, and yes, and that's how it works in a nutshell. So you can, this would be a linear interpolation like we did for the colors, okay? Then you have two of them, then you can determine 2 points in between, and then interpolate this point between 2 points. And the good thing with this is that it's n-dimensional, so you can add a shitload of points, which I will do, like this. But this one was meant to be understandable, so that's why there are bright colors and everything for kids. And yeah, again, with a very simple means, which is a linear interpolation, you can get very complex motions, which is something I'm really after, and I like to... just a second. Too late. This one is not interesting even. Yeah, I think this is where I can draw a shitload of points, which is awesome. Yeah, and the good thing is that it still works. I mean, you can add as many points as you want, and it'll still work, because it's so plain stupid a principle to use. So yeah, well, it gives nice visuals, cheap, nice visuals. Also, it can be used. You may have heard of easing and easing functions. So this is kind of an easing function when you use a cubic. Then you're using this. Yeah, physics. Oh, my favorite topic. Yeah, no, just kidding. I will stop. This was not. The previous was done with Axe Anime. Not this one. This is an old disco number. I was so glad when I did that. I could do this for years. Ta-da! No, just you wait. Ta-da! Such a playful kid, eh? Good Lord. Ta-da! I think that's all. Not much to add. Some serious shit. Sparse matrices. Sometimes in the life of a coder, you get to eat beans. This is maybe you know what a matrix is, obviously, and yeah, this is, for instance, this is a clipped version of the sparse matrix that is used to control this application. So this is an associative array. So okay, say, well, who cares? So inside you can see some sticks in there, maybe, and those sticks are determined by the cross relation that is done in a sparse matrix. I think this is more explicit, and anyway, it's a bit more beautiful. Yeah. So that you relate two dots, and they will tend to come closer to one another, or repel if they are too close. So it's kind of a magnetic phenomenon. And And with a very, 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 very small amount of data, once again, you can build extremely complex structures. Like so, this is a platonic solid, okay, hypercube before that. But you can really have like insanely complex things, like wow, like. But the most beautiful was when they build, like they go from a chaotic soup or something. No. I think I've got this one live, so it might be a bit more interesting. So yeah, you got this pile of and then wow, something. Yeah, and yeah, somehow really, when I say insanely complex, it's like creatures or it's alive. And I think I've got a live version of this, which is like because it's we skipped move. Yeah, that's it. And that was done with anime. Woo. Yeah, that was basically my first test with anime, and to check how Canvas sucked, and it sucked pretty much. And then I did it in C++, and the output not touching a single line of code, of course, and worked much better, much better. Oh, okay. I will stop making a fool of myself. Oh yeah, and there's no end to it, but it will crash at some point. I know, I tried it before. Yeah, water. Let's get down a bit. I was in the forest and I saw this lake. It was a winter. No, just flows are really beautiful, and if you have a chance, just stop by and look at a lake for a half an hour. Maybe it's not the best advice, but the idea is like be more aware of what is around you, because there are so many beautiful, infinitely beautiful things all around. If you just go, not even for a smoke, you'll find those weeds behind, and they have purple flowers. Like, it's not weed; it's not even supposed to exist. Don't know if it has a name or something. It's beautiful, and it's here. So just you open your eyes, and that's what. Water is beautiful, and did you know that water is denser at the temperature of 4 degrees than 0? That's impressive. Oh, DLA. Oh no, not this one. It sucks terribly. Unfortunately, okay, next. Yeah, distributions. That's also something very interesting. I'll try to go fast with this one. So, yeah, this was a lesson I gave also to my students, how to distribute things on a space. And basically dots is first thing that comes to mind. That this was a random distribution, so you can randomize, and then pseudo-random distribution. If I refresh, nothing happens because I haven't changed the seed. This is a circular, of course, then you can jitter a bit the same, so you can have some very interesting. This is very useful basically in websites when you try to represent data or whatever. Disks, frames, grids. This has to be a triangular grid, and and this has to be a hexagonal grid. They look kind of the same. And if you have a distance function, then you can do what's called a Poisson distribution, where if you stare at the center of the screen, you got one dot that is not moving, and you will give me your card account number, and look at the screen. And it prevents other entities to bump into each other. So that's good to know that it exists. It's not extremely useful, but for puzzle pieces, for instance, you want everything to be visible. You don't want things to overlap. Then you can use a Poisson distribution. Now because I've got the second one, which is a bit more sexy. So with lines, again, you can just work with lines. This is kind of what I've shown you for randoms and everything. So this is based on a modulo instead, so it's not random, but you can already obtain linear patterns that like are crazy, like insane. And this was done by a guy called Pixelero, who's from the Northern Kingdom. Well, anyway, so this is the random. This is how to draw a line, blah, 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 blah. Space, woohoo! And then lines, grids. Oh yeah, by the way, this was all the object of the concrete art was to do this. They didn't have computers. They spent a lot of time drawing grids with a pencil, one brush. Okay, lines, curved lines, circle, arcs, and everything. Ah, yeah, oh, that's a spline, I told you. Yeah, this is also a very interesting principle. And again, something that's pretty easy to implement. So there's recursion, like subdivide, and then subdivide, and then subdivide. And you obtain like extremely complex shapes with this. It's insane. But mostly you've got effects! Wow! And that's it. Oh yeah, you can... breaking a line, like you get just some random variations, like having them point somewhere and everything. Just... Okay. What do we have here? Yes, yeah, this is triangles are extremely useful tools. They're everywhere, like in 3D those days. You can't play without a triangle. It's like, and this is Delaunay. Of course, you don't see it. Looks like a plague or something like that. But you can do, yeah, you can do physics too. If this shape is triangulated, turned into a set of triangles, otherwise you can't use it, because in most physics engine will use convex polygons, and then a triangle happens to be a convex polygon. So you can group them, like have lots of them, and that's how you can make very detailed and complex terrains and everything for your games. I don't know if yeah, this was also, it has some graphics interest too, I guess. Like this is a blue lizard from Lebanon, and it's blue only when it's in love. And yes, and you've all seen this type of render, like it's been very trendy lately and for the past years, and I did that for my work basically, and I wanted to do that. And again, an editor, so I think I'm not pretty sure, but yeah, I just left some options to edit and to save, and I gave it to my art director. Deal with it, and he did all the rest, which is pretty nice of him, because I wouldn't. And this was, I don't know if it will work basically. Probably very, very dark. Yes, but it's pretty. It's a popcorn fractal. So it has a bit like the attractors. It has a lattice to which it sticks, and it like kind of moves around, and in a pretty orderly manner. So it's not absolute chaos, like not drawing lines everywhere, but it's oh yeah, I'll send you the link, because this one is really nice. Maybe with darker colors, I don't know. I don't see much. Something is happening there. Okay, yeah, quickly, because I don't know what's the time. I'm late. Yes, you're tired. You want a beer? Yeah, damn. Yes. Okay, because I dance also. I haven't told you. No, you don't. Trust me. Trust me, you don't. And this also was done with enemy. Whoa. And yeah, also for me to learn and for my students to suffer. And this is a cellular automata, and you can run pretty nice things with it. Like again, very simple rules, very simple means, and sometimes great results. This is a complete eye popper. When you look at it and you change the thing, and and what is this? Oh no, okay then. Well, you know what? I think it was a model that was invented for to evaluate the computability of a system, cellular automata. Oh yeah, only pictures, nice pictures. There is this software called Structure Synth that is really awesome, and you code like you generate shapes and everything by code. So you say cube, move, rotate, create new cube, and with again very simple rules, you just change a bit the colors and move, and you obtain very quickly like again extremely complex objects and well, things I find beautiful. Structure Synth is the name. It's there. You can't read it either. And then they have also a renderer that is called Sunflow, and then you have this very global illumination, blah blah blah, nice sweet shadows and everything. Interesting. What is that? I don't know. Is it a bird? No. Okay. 3D curve. It's the same as 2D. In fact, I don't even know. I should remove it. Or yeah. Well, okay. Oh yeah, that was my very first enemy piece. Whoa! Oh, you don't see it? How strange. It's a planetarium, so there's like orbiting planets. I discovered that we have planets that I didn't know existed. Like the furthest is not whatever, I forgot, but you got planets in between, and it changes because they say, oh, is it a dwarf star or a gigantic dwarf star or a small planet? What is it? And they push them away, like they kick some planets out of our solar system with us not knowing. I mean, come on. And in fact, later on, I discovered that this was done by. I found a GIF that I found beautiful and just reproduced it, and it was a guy called Santiago Ortiz, and he's just a crazy guy, like in visualization. So I can't hate them that much, but he's really good, and I was a bit disappointed, but it was kind of an achievement, like to have. It's not very complex, but it was my first HTML successful compile ever. I was so glad, and it runs actually better on HTML than Flash, which is okay. Just one last thing then. Oh, my favorite topic. Look, yeah, that's also something it's perfect because it's exactly what I wanted to show last. So yeah, this is something I've done during a contest like get together code something, and we'll show it on our website, and it was my first try at JavaScript. JavaScript, the word is dirty. And then I used Haxe.js and a very handy wrapper around the 3JS library to tackle the WebGL part. But also, as it was in Haxe, I could also build a small sound module that is used to drive. I hope there is some sound. You can't do in JavaScript anyway. Loved it. And it took me 10 days from scratch, and I could sleep. So not like the busiest 10 days of my life. And yeah, it works, and I was so glad. Like, thank you, Haxi. Oh yeah, and the shape in the middle is turning from a ladyish walk, a bit exaggerated by the way, but into a male. And yeah. And that was it. Enough. Thank you very much. It's fine.
Is any of your work is available? Any source of work is available for download or streaming for?
You mean, do I open source the code?
Yeah.
Yes, I do. Yes, I do. Yeah, most of it was on my website. There was this thread on Google started by Andreas, and he said, "Where are the flashers when you need them? Promote enemy, you bastard!" And I said, first I need to use it properly before advertising or sharing anything, because otherwise it's like. But in the end, I've still, if you're interested, I can just give you a zip with all the things, the material for my students, for instance. This is completely free and do whatever. Even the WebGL thing is online. They just open the repo and it's there, so you can check it and. Okay, or if you want, you can.
Yeah, I have a question.
Yes?
The pictures you showed with the sea and just put pictures or generated?
This is real water.
Oh, this was a photograph.
Yes.
Okay. I was wondering.
I tricked you. Yes. Yes, because sometimes the surroundings, what you've got around you, is so just simply plainly so beautiful that you don't. I have never understood why you want to mimic, unless you want to a realistic game or something. But how you want? So many people want to mimic natural phenomena as realistic as possible. When what's really interesting in water is the endless motion, is like the flows, and not modeling the look of it, but the inner tensions and the inner work is so much more interesting and. Also so much more complex, but yes, those were pictures.
And another question about the last work you showed. You said it's done in Hack.js, but and the sound is in Hackslash.
Yeah, I used Hack. What did I use? Did I use it? Yes. Well, I compiled the Flash with Flash. Yes. So yes. Yes, I had a separate project like with Enemy to compile the Flash, and then the embeds and all the Java shit action was done with this very nice wrapper around the dome, and finally I could understand what I was doing. Like instead of typing point blank, like, I'll do JavaScript. It's easy. My favorite topic. Oh, yes, hello.
So you talk about processing and JavaScript and Flash. Is there any particular language or technology that's your problem?
No. Yeah, JavaScript, of course. No, as long as you can draw a triangle with a texture, I mean, it's any language is good. After that, you've got the learning curve is really sometimes discouraging. Like I know that processing is really easy to learn. There are lots of resources. Hexonomy was really very easy to get into because I could install it and run the first tests very quickly. It was not the case for Android, for instance. I almost committed suicide twice. And and C++, C, all these things are a bit too complex for me because it would take me a lot of time to learn, and I'm pretty sure it's really powerful and it does the thing also, but for now I'm fine with what I found. Just what I would like to do before also releasing some sources is to clean up the shit and then say, hello community, here is your enemy pack, and yeah, trying to share this at least if it can help someone getting started, or because I told you I can never stop speaking, so if you're thirsty we should go. we can continue on the way.
Hi. I wanted to ask you about the electricity one.
Oh yeah.
How does that work? Because I played about using certain noise to do it, but that was quite heavy when I tried to do
it's a recursive. You break the line recursively, yeah. So. Break it, but it's extremely heavy. There's no, with a displacement map maybe, but.
How do you get the animation, the movement?
Oh, maybe I'm mistaking the animation. Which the lightning bolts.
Yeah.
Like this thing moving like this and.
Yeah, because you said you have displacement, but you didn't explain how you animated that.
Okay. Usually there are different for the in fact, it's just targeting drawing a first line, then splitting it into two, and then into two, and then into two, with giving some random, and then you got this noisy aspect. But it's really computer expensive. It's
you don't need it once done.
Nope.
Oh right. Okay.
Nope, I don't. I cheated again. It's like the water pictures. There are very again, it's like mimicking water. It's utterly complex, and there are very cheap tricks, and I am on the cheap trick side most of the time.
The other question was brushes. You tried playing with the aerofoil equation to get a nice brush shape. Aerofoil?
I don't know about this.
Nice shape for the brush.
Good.
I was just very interested in brushes because I've been playing.
Okay. Well, I can type the name somewhere and use it. Yes. Never.
You use this aerofoil as in a wing shape?
Mm-hmm. No, it must be depending on the length, you just shrink. It's too easy.
We see that you love questions. So, anybody with another question?
Beers, we want beers.
1, 2, 3, no. Okay, thank you very much.